At the heart of the cosmos, among the countless celestial bodies that occupy our night sky, there exists a giant that has captured the imaginations of humanity for millennia. Betelgeuse, a red supergiant star that blazes with unpredictable brilliance at the shoulder of the Orion constellation. This stellar behemoth is one of the largest and most luminous stars observable from Earth, yet it is also one of the most mysterious. Betelgeuse's life is approaching its final stages, and with each fluctuation in brightness, each mysterious pulse, we are reminded that one day, perhaps tomorrow, perhaps 100,000 years from now, it will explode into a supernova, an event that will be visible across the entire galaxy. For as long as we have observed the skies, Betelgeuse has stood out not only for its immense size and brightness, but also for its erratic behavior. Unlike many stars, whose luminosity remains relatively stable over long periods, Betelgeuse seems to live in a state of constant flux. As recently discovered with the James Webb Space Telescope, the brightness increases significantly, increasing by 150% in a few months. This mysterious burst of energy is a reminder that Betelgeuse is undergoing internal changes as it nears the end of its life cycle. For astronomers, this increase in brightness is an important opportunity to study what happens in dying stars and a sign of a star's imminent demise. But when will Betelgeuse finally explode? This is a question that has puzzled astronomers for centuries. Despite the clear signs of stellar instability, predicting the exact timing of a supernova is a challenge fraught with uncertainty. The scientific community is divided, with some experts believing Betelgeuse will explode within the next few decades, while others, including NASA, say it may not go supernova for another 100,000 years. This difference in predictions shows how difficult it is to study stellar evolution, especially for massive and old stars like Betelgeuse. But what is clear is that when this event occurs, it is one of the most amazing phenomena that man has ever seen. When Betelgeuse explodes, the effect can be seen and felt far beyond its surroundings. Supernovae are among the most powerful explosions in the universe, releasing more energy in periods shorter than our sun's lifetime. Betelgeuse's supernova light is so bright that it outshines the moon and is visible during the day. For several weeks, the night sky will be dominated by this fiery spectacle, an unprecedented global fire show. However, while we await this event, we must also recognize the incredible scientific value that Betelgeuse offers in its current form. With each dip in brightness, each new burst of energy, we come closer to understanding the complex processes that govern the lives of stars. The appearance of Betelgeuse is not new. For thousands of years, this star has fascinated astronomers and astronomers. Ancient peoples, from the Aboriginal people of Australia to the ancient Greek astrologers, carefully observed the periodic changes in the brightness and dimming of the stars. These early observations helped introduce the Betelgeuse into the cultural traditions of many societies, where it symbolized power, change, and cosmic significance. Historically, Betelgeuse exhibits a very predictable brightness cycle, with variations approximately every 400 days. This simple pattern allowed early astronomers to map its features with great precision. However, this trend has changed dramatically in recent years. Recent observations using advanced telescopes such as the James Webb Space Telescope and the Hubble Space Telescope have shown that the cycle is less than 13 days. This sudden change has puzzled astronomers. What is the major change in the behavior of the star? The answer may lie in the complex internal processes that govern the Betelgeuse's life cycle. Betelgeuse is a superman and is nearing the end of his stellar journey. Stars of this type have run out of hydrogen fuel in their cores, resulting in massive mass and instability. As the star burns through the heavy elements in its core, it begins to explode regularly, leading to the sudden changes in brightness that we see now. These rapid changes indicate that Betelgeuse is undergoing internal changes, possibly representing the final stages of its evolution before it explodes. For astronomers, these variations are an important opportunity to study the red giant star in its final phase. By monitoring changes in Betelgeuse's brightness and surface activity, scientists can gather valuable data about what happens in dying stars. Each observation brings us closer to unraveling the mysteries of stellar evolution, possibly predicting whether Betelgeuse will go supernova. While we may not have all the answers yet, The ongoing study of Betelgeuse provides a unique insight into the life cycle of one of the world's most beautiful stars. One of the most important events in the history of the planet occurred in late 2019, when Betelgeuse encountered a previously unknown event. Over the course of several months, the star's brightness drops by an astonishing 60%, a phenomenon that can only be seen by casual observers. This sudden change in brightness, known as the Big Approach, has sparked the imagination of astronomers and astrophysicists. Many believe that Betelgeuse was on the verge of going supernova, which increased the scientific community's anticipation and excitement. But when scientists take a closer look at the star, another explanation emerges. The large size is not the beginning of a supernova, but the result of a large surface explosion in Betelgeuse. The massive explosion threw a huge cloud of dust into space, obscuring the star's light as seen from Earth. The dust cloud was so large that it blocked out most of the light coming from Betelgeuse, causing a significant decrease in its apparent brightness. This discovery is important for several reasons. For researchers, it is a great learning opportunity. By studying the dust cloud that enveloped Betelgeuse, astronomers gained a better understanding of the processes that cause the red star's surface to function. These stars are known for their instability, and events like the Great Dim provide rare insight into the complex interaction between the star's outer layer and the surrounding space. This knowledge is important for predicting the behavior of other red giants and preparing for a supernova that may one day occur. To fully understand Betelgeuse, we need to understand the scale of this celestial giant. Betelgeuse is classified as a red giant, a type of star that has run out of hydrogen in its core and expanded to a supermassive size. After all, if Betelgeuse were in the center of the solar system, its outer layers would extend beyond the orbit of Mars and close to Jupiter. This sudden size is difficult to understand, but it is important to the behavior of the star. Betelgeuse's size means that the outer layers are only connected to the core. As a result, the surface of the star is highly unstable, and large convection cells form that move hot gas from deep within the star to the surface. When this hot gas reaches the outer layers, it cools and sinks into the core, forming a kind of stellar conveyor belt. This process not only disrupts the star's atmosphere, but also contributes to the brightness and dimming of the time we see from Earth. Betelgeuse's size affects its energy. Because the star is massive, the gravitational pull on the surface is weak compared to smaller, denser stars. This allows Betelgeuse's outer layers to expand and contract more easily, leading to fluctuations that cause the brightness to fluctuate. Understanding this structure is key to understanding the life cycle of red supergiants and the processes that lead to their destruction. The formation of Betelgeuse is not spectacular in its own right, but it provides important clues about the final stages of a star's life. As Betelgeuse continues to burn heavier elements in its core, it reaches a point where it can no longer sustain nuclear reactions. At this point, the core collapses under its own power, resulting in a supernova. By studying the structure of Betelgeuse, astronomers can better predict how and when this process will occur. One of the most important signs that Betelgeuse is approaching its final stages may not be the moon, but a different source: neutrinos. These complex particles are produced in large quantities during the final stages of a star's life, especially when the core begins to collapse. Neutrinos are unique in that they can travel through matter unhindered, making them one of the few particles that can escape a star's core even if it collapses. When Betelgeuse reaches its collapse point, it releases a flood of neutrinos that travel through space to reach Earth. These neutrinos are one of the first signs that a star is about to explode and come in front of the moon from the supernova itself. Seeing these neutrinos alerted astronomers that they could observe a supernova from its inception. Several neutrino observatories around the world, including the Super Kamiokande in Japan and the Ice Cube Neutrino Observatory in Antarctica, continuously monitor the sky for signs of these particles. When the first wave of Betelgeuse neutrinos hit Earth, it caused an alarm, prompting astronomers to keep their telescopes focused on the star. This real-time observation of a supernova is a once-in-a-lifetime event, providing valuable data on the process of star death and the formation of heavy matter. The study of neutrinos is a relatively new field in astronomy, but it has already shed light on the inner workings of stars. These ghost particles are produced during nuclear reactions, and their behavior reflects the core of the star, a region that cannot be directly observed. By studying the neutrinos emitted by Betelgeuse, scientists can better understand the final stages of a star's life and what happens when it goes supernova. The detection of neutrinos from Betelgeuse is an important event in astronomy. For the first time, scientists can watch the death of a star over time, from the initial collapse of the core to the subsequent explosion. This not only deepens our understanding of stellar evolution, but also provides new information about the fundamental forces that govern the universe. As we await the arrival of these cosmic messages, we are reminded of the power of discovery that lies within the stars.